Welcome to UR Tech Partner, your ultimate destination for mastering AI and DevOps. Dive into the world of cutting-edge technology with us and unlock the secrets of artificial intelligence and development operations. Stay ahead of the curve and elevate your tech skills. Learn AI and DevOps with us today.
Okay, hi everyone. With the continuation of the previous video, we have discussed in previous video the Docker Compose, and let's now discuss the Docker Swarm with the concept as well. Okay, let's first draw something to see that what is the problem. So in the previous video, we have seen that Docker Compose is really helping you in a great deal when you have multiple containers and you cannot go there and run uh, images one by one there, manages them if something dropped, add new container. There are multiple scenarios we have discussed in detail. Great. Well, Docker Compose make our life easier, but there are some other problems we have discussed in the previous videos as well, that there are some extra feature needed when the complexity scale is getting bigger. What is the complexity scales? Complexity scale that in previous video we have discussed that we have need sometime like more than 72 or 100 containers to manage for the all three environments, because if we have three environments and each environment has three copies of each service, and we have three servers and three service in total, or four service in total, so in total we then need 72 containers. Well, managing them or trying to doing some configuration or creating them is the one part, but the main part or the important part which is missing is the auto balancing, auto scaling, and automatic self-healing. So these are the three primary principles or the concepts which were failing actually in the greater detail when it comes to a Docker Swarm, and that's why Docker Swarm has come into the picture. So let's discuss the this problem. So I mean, this concept is very important. Auto scaling. Auto scaling is nothing but when you have, for example, you have created three virtual machines, V1, V2, and V3. And inside, you have some container. You have container one, you have container two, you have container three, multiple container for each thing, right? But for example, multiple containers are inside, but the real problem really is that what happened if, for example, I have given the example of the insurance where we have multiple insurance. For example, we are health insurance, we have provident fund, car insurance, legal insurance. We are our business just dealing with the insurance company. In start, for example, we are thinking that only 1,000 users are there, but might be over the time our service is very successful, and turns out that hundred of thousands of people are actually using this service. So for that scenario, actually, there should be a service that should automatically scale out. So there should be a service contained in the environment where it could double themselves. And if needed, actually, it just create another layer, and now it's automatically have created the double service and expand itself in the elastic mode, right? This is the scaling. And when it sees that over the certain period of time, because of Ullov or because many people are going on vacations, might be the usage of the services remain only 50,000 calls per month or per period, and then it's automatically like kill these sources so that it can save you some resources. That is the auto scaling where you automatically expand based on the user need. And when there is less need of the usage, it's automatically shrinks. It is elastic. So the thing is that it should be elastic. Any auto scale service should be elastic. And next concept Yes, next concept is what is the next concept? Next concept is auto scaling, and what was the second one? Now I'm forgetting the name. Load balancing. Load balancing. Now, load balancing is nothing but, for example, if you have multiple computer instances here, and you really want to somehow you have here many computer, and you really what you really want to do is that you really want to balance them out. For example, you get 100,000 calls. Let's say like that you get 100,000 calls here, but you automatically distribute them in the way that distributed by number of computer here. For example, 1, 2, 3, 4, 5, 6. In total, we have 18 computer, and the call is automatically distributed into the 18, and then it's goes equally. Each calls are going equally to them, so it's a load balancing. That load of 100,000 requests is equally distributed to all the nodes or the grid in the computer, which is a great thing in the end because this is needed. For example, if what if these all calls are completely gone to this server and this service is overloaded and the efficiency is not good. But it is if it is intelligently distributed, then it's a great thing, right? And then the next concept, which is very important, is self-healing. Now, self-healing essentially means that you have running multiple container here in the row to do some job like in your app or whatever you are running here. You're running your app in the three equal services actually, which is connected to each other and serving something, or might be their independent container. And what happen if one container, these are the container, and this container is gone? It's going to inject automatically a same container, same replica from here. It's going to provide you another container with complete same details and same configuration. And if this is gone, then it just get replaced by this one, and your system is still on the replica 3. So that is the concept of self-healing, that any container due to the any reason destroyed, so then it's really helping that. So these are the major portion I can say, or major three points where actually Docker Swarm helps you. And then comes number fourth really is that number four really is a single point of failure. So we have discussed that single point of failure is a big problem in the world of Compose. Um, because might be it is running on only on a so well before the advent of this Docker, we had a virtual machine concept to the monolithic structure of application, and everything was contained in one big server. That was a big failure, prone to big failure here. Security was it's a sad thing, but Docker Compose managed somehow, somewhat. But still, the point of failure problem is still there because most likely that these containers are managed on the virtual machine, which is also single point of failure, and it doesn't really helps that. And now we need something to protect the issue by single point of failure, which means that we distribute overload to a multiple master. And how Swarm does that? It's very easy. It's declare one machine as a master, and it has some nodes to this similar infrastructure. It has some node to this similar infrastructure, right? And then it's actually what it's doing. So it is connected to the multiple nodes here. It's somehow connected to multiple nodes here. And this is, for example, in one, this is node 2, and this is node 3, and this is M1. Even we'll discuss in the further different videos that even it also give you a multi-master architecture as well. So it is possible that master somehow get destroyed or failed, and then you need to somehow come up with the idea of replacing the master. So then master is also very important here. So it is called multi-master architecture. Otherwise, it's a single one master and three nodes architecture here, right? And how you do it is very simple. We're going to do it practically. It's a very simple stuff. So you declare one of your machine as a master. For example, I declare it as a master and I run here simply Docker swarm init. Right here, I have written it. So you just perform this command here and Docker swarm in advertise address and the IP of the address, and then it's going to give you a token which you need to perform here, here, and here. As a prerequisite, Docker is installed here, Docker is installed everywhere. So Docker must be installed on each machine in the question. So every machine must have a Docker install file. So let me just show you that how you do it. For example, here I have VirtualBox. In VirtualBox, I have one master node. I double click on each of it, and then really I end up to this, not this, I end up to actually these machines, which are different machines. And where is number three? Yeah, this one is number three here. So might be I can show this as a master. This is, I can shrink this up a bit. So this is kind of one, and this is node two, node one, node two. Okay, and node two is, for example, here. So that's pretty much structure here. So we have installed three Ubuntu computer to show you, and let us see that if anything is already running or not. If I go here and if I clear it up, Docker service list, there is one service which is running. Docker service remove my swarm. This is the server which I have killed right now to just show you from the fresh. Well, the first question is how you install the Docker. Let us just install a Docker. Let me just clear it up, clear it up. On that machine, I have lslpr, and I have this small script which essentially install Docker. In the previous video, we already have in detail introduction how you install Docker actually from complete scratch. You can follow that same, or I have that install.bash, which is kind of just mm, more robust way, and these scripts are easily available on internet. It's actually trying to see that what you have Docker or not on the sockets. If you not have that, you must install, and based on different operating system you're running, it's automatically detect and add that version, and then different stuff. How you do this? You just go bash and then install, and you hit that, and you that hit enter, and then it's going to read the database. It's downloading everything, preparing the configuration for you. And the link of this, I'm going to actually, if I really do that, It's doing whole stuff, and I'm going to attach that for sure in the description, this such a script, so that you can come up with that. So I just canceled it this for now. Docker ps sudo docker ps whatever docker is installed here, sudo docker is installed here, sudo docker 1 2 3 4 5. So it's also installed here because it's showing me some values here. So here docker is also installed, which is a great thing. We are ready to go. So first thing first, we need to do, we need to know the host name. We need to know the this IP address of that. And what we can do is docker init, docker swarm init, and then I can say advertised address is this one, and I hit enter, and it says me that it's already part of your system, and everything you right here, it's already attached. So what you can do is that you can first leave it. Docker swarm leave. Okay, and the node is already part of this swarm, Docker swarm leave. Nahi, leave and maybe force. No, force, force, and now it has gone, and now I can again say this, and now I have this false thing written here, and there you go. You have again this message that you have been assigned, or you have assigned this computer as a master. And if you want to init, so you need to go here, very simple, and you need to just perform easy peasy here, this. And it says permission denied because somehow you need sudo rights, and well, this node is already part of this farm docker because the port number is same and the IP is the same, and this is already is a part of that, and this is the already this is also the part of that manager. I have shown you before how that manager works, sudo docker, and this is already a part of, and I can say that docker services node, docker node ls, and it's going to show me that. Okay, so this is I have made this as a node actually, but uh, now the token is different actually, but I need to delist them and then add them again to the, okay, now internet has gone, shit. Okay, just give me a second, my internet connection has gone, and this is the persistent problem. I need to find some solution for it, but I must have to leave this as well, Docker on all the computer. Docker swarm leave ports. Okay, I need sudo right for that. Node left. And now whatever I have here, it is very important. This token here, I need to copy this whole exactly what being said here. I can go here, or we can maybe do like this. And here I enter this token. And the bad thing is that I haven't give the right sudo. The node has joined as a worker. Do that, do that. And I can also do very similar stuff here. And it gives me a message that my node has been attached here. And Docker node, Docker node ls should give me all active node address. And it says me that prod nitro VM. These are the name of the machines actually. And if I come here, there's a VM already. This machine is nitro, and this machine is prod. So these are the part of the cluster already. And we have discussed why the cluster is very important, because if something went wrong with one virtual machine, it's automatically replaced by other. And all your containers are equally distributed across the cluster, which gives you extra security and ultimate availability or good availability as well. Well, great. So now let me just I have downloaded one image here. So let me show you. Maybe I can do this here. And Docker images, and this is the image which I have simple. This is simple Python app. If you guys are aware with Python, you have Django or the Flask. These are two modules where you can create a small website, writing HTML code and everything. And this is the image built on the Ubuntu, and something installed here to just show you that how stuff really works, like container ID. And I'm going to create a new services. And with the new services, I'm going to create a cluster of 7 containers, and these 7 containers would have same application, sample app.pip, pip Python app. And what does that? If I show you Docker ps, okay, this container is already running. And if I say Docker execit, and the process is bash, Docker ID or Docker name, I need that here to paste, and then the process is the bash. And if I go here, and if I ls here, and if I cat my app.py, you can see that from Flask import, I have imported something, and it's just a small reroute, and the root is the root, simple root, and this is the text I'm going to get name. Get name is the function which I want to run on the root. And what does it does? It just printing me a message. And socket.get host name is the command that give me that on this socket what is running, which container is running. And here actually app.run is running this application. That's all. That's all. So this is the container running here. So let me see if any other container are running or not. Docker ps a. Okay, this is the only container running on the port number 10,000. And as I have shown you that how that works. So let me just do one thing, that clear it. And now I create a Docker service, which is from this image. I can say Docker images first. So I know the images, then I can say Docker service, and I can see that how Docker service create template works. Maybe I can see. Okay, it doesn't do that. And I go here and I know that I could create a services with Docker services create. Then I can supply any of this option here. And then I can mention the image. And after image, I can mention any command of the Docker, which is already before the Docker command, which means that port number, detach mode, whatever command working with the Docker. And great. So for that purpose, I can say Docker service is the module I'm going to running. Create is the keyword. Name is my swarm, and then replica is equal to I need to run a 7 container on top, and then maybe I want to create a port number here. I can define the parameter before image or the after image. Port number is 10,002 might be, or 10,002. I want to map to the 3000, as I have shown you that by default custom port on the Python app is running on 3000. I need to make this Django port number where Django is listening is 3003. And this is the service level port mapping. And there is very important concept regarding the port, which I need to discuss because this is the another very beautiful solution or the efficiency or the feature that only Docker Swarm gives, or that is available to Docker Swarm rather than any Docker Compose or something like that. And now here is the time for image, which is LERN Learn DevOps 2. This is the image we have downloaded here. And now if I hit enter, it should create sources, or at least start creating sources. And great. Oh, cool. Docker services, PS service name. So to get the service name, we need ls. And this is the service ID have been created, and this is the port number mapped to the 3000. Now I'm going to tell you that how port mapping is important and what it's doing here in this 7 replicas. 7 out of 7 are created. 9, I know that Docker service, PS, and my service name, which is that. And it shows me that on port VM Nitro, different computer names, these services are running, and these are running very beautifully. And this process, this image has been successfully running. Number one. Now, normally what happen is that in the manual Docker Compose, you should have some mechanism for every port number. For every port number, I mean that every container is supposed to run on different port because they could not map to this one single port, because if it is 10,000 for the second node it should be 10,003, 10,004. I'm talking about this one. And if one of your services is down, the automatically it should get up with the second port, but you manually have to change in the web address. What I mean, for example, right now if I write IP of my machine, which is hostname dash I, and the first IP is my machine IP, for example. And if I go to browser here and here I write 10,002, for example, you see that this app is running on the browser and giving you the ID, right? But now, for example, what we have discussed here that any one of container here, for example, in the multi-model structure, any one of container here has gone. For example, any of the container here has gone, or any container is shut down, definitely the port is shut down too. And in browser, you have to go manually there, and you have to write manually, here port now my second container, which is mapped to port number 2003, and maybe I can run this, but it is unable to connect. Why? Because the port mapping is manual in any container style. And what do we mean by the manual? We do mean by the manual that the port mapping is doesn't handle automatically on Docker Compose or any other service before to that period of time when the Docker Swarm comes into the market. But Docker Swarms also give you another efficiency, which is which I believe is the top of the all. Or the most important of all, I would say is that auto port mapping to the clusters node. You just need to know one port, and you give that to the DNS. DNS translate into the human readable address. For example, my health insurance.app.health You just write app.health and it automatically figure out that which container is running where. Automatically does load balancing, automatically does everything for you. That is the beauty here. So for example, as you have seen here, that the container ID is different. Now, if I go here, mm, how I run this, so this is always something like that. For example, if I go here and I run this like that, and I show you that Docker container PS, for example, um, Docker PS running containers. So there are two IDs running here on this VM as shown by here. And if I run again here, Docker PS, add Docker PS, so it's the same, sudo Docker PS. Some of the three containers are running here too, and might be two of them are running here, Docker PS. Well, the two containers remaining are running here. Now, if I show you how automatically it does the trick for you, if I refresh everything, you see the name of containers always change. The container ends with 5C lives somewhere else. Container 5C, if I make it bigger, might be somewhere on the so the container with ID 5C is nothing here. It lives maybe on here in this computer or this computer. The ID is this one, this lives here on the Nitro, but it automatically shown on the virtual machine IP, which is actually this one. And if I rerun it, now it has C3, which is somewhere here. And if I refresh, maybe it's a E. Now it's giving me this container. And as you have seen, that port mapping does automatically change it and automatically map to the port, don't do the networking stuff under the hood. And we have seen in the previous tutorial that we can only map one port of the container, which is here, which I can show you maybe on the here in this computer. Docker PS, and that was the previous container, this one running from 2 hours. And here you can see that 10,000 port is mapped strictly to 3000. And if I create another copy from this container, I cannot use actually 10,000 port because it is already running. I cannot use it. I can show you. If I run Docker spelling, Docker run, and maybe the port, and I'm going to use 10,000 and want to map to the 3000 again, and want to run it in detached mode maybe, and learn DevOps version 2. Okay, It says that it's unable to find image which makes sense. Okay, here is you have seen that 10,000 failed port already allocated. And if I try to run this port because this container, so this is not part of Swarm right now. This container is, as you can see that this is not part of Swarm. If it would have been part of Swarm, if there's my Swarm, like name of the services should be attached to the all computer. But this is the previous container for the showcase purpose. I get into it to make you sure that what is inside the container here, for example, somewhere. So I have shown you that what is written in the my app code or the Python level application, and you cannot map one port on multiple. But in the case of Docker Swarm here, Docker service PS my Swarm, and you can see here that Docker service service list. If I show you that if it is only one port mapped to 3000, but technically there are 7 containers are running, but it automatically figure out the port and do the networking stuff in the background. We'll discuss in greater detail. That's how it does in the networking session. Docker like container networking session. We'll discuss this in a greater detail. But the important thing is that you only know this port, and this is also practical. For example, nobody sits there nowadays and go there and say, for example, that every ID and port is connected to the address with DNS. And what is DNS? For example, everybody could not remember the name of IP. And I am saying that please translate this whole address as a app.healthinsurance.com, app.health.com. So maybe I translate this address into this, and this is called DNS. And any address you see here, it's always that. And for example, if this port mapping is not automatically beyond the scene, then if one container is gone, then you need to manually go there, check the port number of the container, and add that container, which is very sad. So yes, how beautifully this is managed, how and how we can see everything. And that's how Docker Swarm does the trick for you. It gives you a lot of benefit, like 5 main core benefits: self-healing, load balancing, auto scaling, and these 5 benefit it gives to you. And on top of that, this port mapping is very efficient, and this clustering network make it foolproof. But there is still one issue, and issue is what happened if this guy has gone. Great. Even though this guy has gone, the service is gonna run, but the management or the master node management has gone. For that purpose, the people come up with another structure which is called multi-master MM. And we are going to discuss this and then some of the networking in the later on video. Thank you very much for watching. Bye.